All right, welcome back. We're week 11, part 2, module 2. Module 2 is going to cover strings, string and list methods, and exceptions. This week we're just going to go through 2.1 to 2.3 and talk about some string methods and some other little important tidbits. There is only one assignment this week. It should be easy. So, yeah, easy week. All right, jumping right in. Right in. The book's going to talk about strings and lists and how they're compared. This changed probably last year. So we already talked about that. Remember, a few weeks ago there was an assignment where we were comparing strings. Same word, one of the words was capitalized, and we looked at this list here. We determined that because of the way they're compared, the lowercase string has a higher decimal value. Like the lowercase a there has a 97, where the uppercase a has a 65. So when you're comparing strings, the higher value goes to the lowercase number. It's pretty much telling you the same thing. That didn't used to be there, but it is now. They're going to talk about internationalization, Unicode, UTF-8, and basically all these standards allow people anywhere in the world using the same language or the same programming language to look at each other's code and understand what's going on. Without standards, it'd kind of be willy-nilly. But this way, it's all if we all follow certain guidelines, we can work on each other's code and we know what's going on. Where I'm going to pick up is multi-line strings. So if you haven't been commenting your code, you're kind of doing yourself a disservice. If you want to go back, like you say, you work on a project, you make something that does something interesting for you, it's useful, and then you get it to a point where you like it. 6 months later, you learn some new stuff. You want to go back and make it better. You're going to look at your code and you're going to get confused because your future self thinks differently than your past self always. So comment your code so you know what you're doing. Put a line, just a little line of code saying this line does this, or if you have a function, say this function operates this way, and that will help you in the future. It'll also help you if you start working with other folks that are coding. They can read your code, they understand what's going on, and there aren't any issues. What I'm just going to illustrate here is three single quotation marks with a large string in the middle. Now, if you'll notice, when I paste this in, this is called the lorem. If you're not familiar, it's a space filler that programmers have often used. It means something in Greek. I'm not sure what. I looked it up one time, but it's not important. It's a long string. If I back out here and you see this line in your IDE, your code should never be any longer than that. We want to keep it short on one screen so that we can see it and see what's going on. So you want to make this, I'm going to hit enter in here a few times and make it fit on one screen. But as long as it's contained within these three quotation marks, Python won't read it. And this is how you do a block quote. So if you need to write something particularly detailed in your code, that's how you do it. Something that is interesting to me is that you can also declare a string variable this way. If you have a really long string variable that you're going to print on the screen for somebody, you can declare the variable this way with the same three quotation marks. And if I print A and hit the button, you can see that it prints the whole thing. So that's neat. I'm not sure if you'll ever need to type a big string like that. Your output's generally neat and concise, but that is something that you should know just in case you need it. Put it in your pocket. The book's going to talk about concatenation versus replication. Why they're even comparing the two, they're completely different. We know what concatenation is. I have used that cool word a couple of times. Hello. And we know that if we type print A plus B and run it, it prints hello world. It concatenated the two strings. Ta-da. Replication is a bit different. If I want to A times 5. If I just want to print hello 5 times, I don't have to do 5 different print statements. I can just hit A times 5. And that's it. That's how you replicate. The book is going to go over this stuff better, but it's really simple. Really simple. We'll talk about the ord and the character functions. Ordinal. I'm not sure if that's decimal. I guess you could kind of think of that as decimal. Let's see. A was, let's pull my handy dandy little chart back out here. So on this chart, you've got the decimal, you got the hexadecimal, the octal, your HTML special character, and what the character is. So if I'm looking at the A, lowercase a, the decimal is 97. Uppercase A is 65. I don't know if I'm going to remember that. So if I want to, if I just type print ord and put the string A, the lowercase a in there, what's that? I should print 97. 97. Okay, so this ordinal function is how you get the decimal value of a particular character. Again, we're talking about comparing strings and comparing strings. So the ordinal, the opposite of that is the CHR, or I call it character. If you have the ordinal, but you don't have what it goes to, if you don't have that handy list, you can do this. If I run this, it should be 97 in A. And again, this is talking about how strings are compared. So that lesson that we did earlier, I'm not sure if it went into this kind of detail or not. But this is exactly what it's doing behind the scenes, right? For I in A, we're going to do something. N is going to be equal, or we're going to add up the ordinal value of each one of the characters in the string of A. So let me do N is 0, and let's add an M in there just for the measure. And then we'll do the same thing for I in B. M is going to be the total value of ord I. So we're going to count for every letter in the string A, a lowercase string. This is a lowercase s and this is an uppercase s. I'm not sure if you can see that on screen. But we're going to add up all the values of all the letters and see which one is greater. And then print N, print M, and run it. So we can see the values here. The variable A, which is the string with a lowercase s, the value is 663, where the value of B with the uppercase s is 631. So that's how we can see, based on the lesson a few weeks ago, why one particular string is greater than another. This is exactly what it's doing behind the scenes. So now you know how to even do that on your own. Again, I'm not sure when you'll use this, but it's good to know. Let's do slices. I'm going to talk about slices. A, B, C, D, E, F, G. That's good. So we've done this before too. And we did like 1 to 3. I don't know if we did that or not. But what is this going to print here? It should print, I think, Does it include? I can't remember. Hold on, let's see. So it prints B and C. So A is 0. Remember how they're indexed, 0 through whatever. A is 0, so it's going to print 1 and 2. It is not inclusive of the last digit that you put on there. If I do this, A3, nothing. If I just leave it blank, it's going to go all the way to the end. So it should start at C. So we should get C, D, E, F, G. Hold on. 0, 1, 2, 3. No, we should get D, E, F, G. Again, because we're starting at 3. And remember that it starts at 0. 0, 1, 2. And it starts printing 3. And it'll go all the way to the end. If we do kind of that backwards, leave the front blank, and we'll just go to the third one. We know that 0, 1, 2, 3 will D. Probably not inclusive. Let's see. Yep, we just get ABC. It does not include the D, or which is the third index. So remember, if you put something on the end, it is not inclusive of that one. It's just going to get the one in front of it. Let's do some minuses. If we go 3 to -2, it should go 1, 2. Yep. It goes from the back here 2 spaces. This -2, if it's a negative, it means it's going to read from the right-hand side versus the left like normal. So you get the third index, which is D, and then it looks at the end and then comes back in 2. It ignores the first 2 and gives you the E. Print like, let's do -3 to 4. What's that going to do? One, 2, 3, 4. That doesn't work, obviously, because -3. So 1, 0, 1, 2, 3. 4 is the E, and it's also the -3. Maybe it should have just printed the E, but it's not inclusive of the E. So maybe if I do, I don't know if this will work either, because it seems backwards to me. Yeah, this is backwards. It's not going to work. I don't know why that's an example on my paper. If we do something like this, what do we get? A, C, E, G. A, C, E, and G. So this is going to be steps. It's going to print everything because we don't have anything on the first column, or first colon here is looking for a start and a stop position, but we don't have any. So we're just saying go from the beginning to the end. This 2 is a step. So it's going to print every other one. And this way it's printing the A, C, E, and the G. It would do the same thing. It'd be the same as if we went from 0 to 0, 1, 2, 3, 4, 5, 6. Is that right? I don't know. I'm counting quick. Should do the same thing. A, C, E, G. I just go A, C, E. Because that'd give me out of bounds there. Nope, that works too. 1, 2, 3, 4, 5, 6, 7. Okay, there are 7. So it's the same thing as like 0 to 7 because there are 7 variables in there. And it steps over 2. So just remember, you can put a start variable, a start index, an end index, and a step when you're doing slices. I might do the same. This would probably do, let's see. I guess it's common practice, like if you see in this example here and this example here, if you're going all the way to the end or starting all the way at the beginning, you don't put anything in there. It just knows to start at the beginning and go to the end, which is the same thing we're doing without this here. But if we do 1, it should start at the second one, DBF. So this gives you, it starts at the 1 index rather than 0 index, and then it steps every other one after that. It's a good way to get odd and even, if you know it's like that. But that is slicing and a plethora of ways for you to do it. When you're working with strings, you'll want to know all of that stuff. So some of the differences between lists and strings are like a list is mutable. You can change the contents of a list variable. A string is immutable. You cannot change it, just like a tuple. You cannot change it in the program. It stays the way it is. For that reason, you can't use the delete method. You can't use the insert method, and you cannot use the append method with strings. You can with lists. These are list methods only. You can't use these with strings. However, the append is a lot like concatenate, throws it right on the end. So it's very similar, but different. Some things that you can use with, there's a lot of them. A lot of things that you can do with strings that you may or may not use. For instance, like if you're working on a program that does like employee information, that kind of thing, a lot of people are lazy. You're taking in user information, and if they're lazy like me, they won't capitalize their name, but we need it capitalized for the right, we need to capitalize for the record, just so it looks neat or whatever. So if you use the upper, well, it'll capitalize the whole thing. This is how you do a function. To the string, you do a dot. You know, the string method. So we did this in a few other projects. Upper is the method and the string. So string dot method is how you apply this. This does upper. If we want to just do it like it's supposed to be, we use title. And it's going to capitalize it like the title of a book. You see, it'll just title the first and last name here. Some other useful methods, like is alpha, is digit, is upper. Let's say you want to, anything you're taking user data in and it needs to be in a certain format. You want to be able to check and make sure they didn't enter characters when they should have entered digits, or digits when they should have entered characters. We would do something like M-N-O-P Q-R-S-T W-X-Y-Z. So we have to iterate through it just like we would a list to check each one of them and make sure it is, in this case, a character and not a digit. So to iterate through it, let's see, we're just going to do for letter in A. Now remember, this can be anything. We can make this for I in A, for thing in the variable. But just for simplicity, we're going to say for letter in A, which is the string variable, if the letter dot is alpha. And this is going to check and make sure it is an alpha. We're simply going to let it pass. Else, we're going to print there is a non-alpha character. So this is where you would put your error correction. Maybe ask them again or tell them, hey, idiot, you put in digits and it's supposed to be a character. Variable. And then we'll break. And then outside. Dang it, come on, hit the enter button. And then if it finishes, we'll print that if it doesn't ever get to that break, all of the information, I don't know, is alpha. It's just an example. I wouldn't use this code in the program. But if we run this, and so our variable is the alphabet, basically, no spaces, no periods, none of that. It does not break, so it gets all the way down to all the information is alpha. Now if I put a digit in here and run it, it still gets to this. This is outside. So that's an error, but you can see it did get here and say there is a non-alpha character in the variable. And if I take that out, we will not get that. So it checks each one and makes sure it's a variable. If we want to do digits, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, let's put a 0 in there. So we're going to check this is digit instead. And if it goes all the way through, we shouldn't get any output. And we don't. And if I sneak a letter in here somewhere, it finds it and it says there is a non-digit character in there. What I find interesting about this is that we've spoken about different strings versus numbers, integers, floats, regardless. This whole thing is a string, so it recognizes the whole thing as a string, but it sees the A as an A, and it sees the numbers as numbers. Even though it's a string, it recognizes it as a number. And if you don't understand what I'm talking about, if B equals 5, you see it's blue, C equals 5, but in quotation marks. B is a number, an integer. Let's see if I can even run that on B. What will happen? See, B is not iterable because this is not a string. It's a number. If I run this on C, oh my goodness. Run this on C, it should work, but we get nothing because it is a digit. So these are methods you run on strings. I just find it interesting that it can still tell a digit from a number, even though it's not a number, it's a string. Or it can tell a character from a number. Anyway, unimportant, I suppose. So there's is alpha, is digit. And if we go to the assignment for this week, your assignment this week is you're going to take input from a user, me. And I'm going to use the same sentence. When I grade these, I have a sentence. I'm just going to copy and paste it in everybody's program and run it. And I should get this exact output. You need to create a program that takes input from a user, and I'm going to enter my sentence, and then it has to run on something. So you need to look for digits, which we showed you. You need to look for alpha characters, spaces, uppercase letters, and lowercase letters, and it should count all of them. So again, count all that stuff, and you're going to have to define now there is a function that you can use. If you go squirreling around the internet or steal somebody else's code, you can find a function that will look for punctuation of sorts. But I want you to create your own function that looks for these specific punctuation marks, periods, question marks, commas, colons, semicolons, single quotes, and double quotes. I want you to define a function that does that. I don't want you to go out and use a function you find on the internet. So most of these are done for you. The is digit, is alpha, is space, is upper, and is lower are all done for you. All you have to do is type it in because Python already has them. I want you to create and define a function that looks for these punctuation quotes. Now all you have to do is set it in a string, just like we've done on several occasions already, I think. You're just going to define a function that takes in a sentence, and if we need to go for letter in sentence, if letter, let's do in list, and then count, increment, whatever variable you use for count. This is not good code. And again, a lot of you have been copying or just typing what I've got on the screen. I want you to think about this for a little bit. So you can do your lists can be like this. Period. No, you have to do period, comma, colon, semicolon. I don't remember what else I got on there. So here's half of it. You also probably need to find a count. This is half of it. This is some of it. This is a taste of it. You're gonna have to fix this. Don't turn this in and think it's gonna work. And I want you. Some of you don't test your code either because you give me stuff and I get weird output. Test your code. Make sure it works before you send it in. But you will do it something similar to this. You're gonna define the function is punctuation. It's gonna take in that user data. It's going to compare the user data to this list that I listed in the assignment. And I don't know if you can see that if I don't back out, but you'll see it when you open it up. It needs to look for periods, question marks, commas, colons, semicolons, single quotes, and double quotes. Put all those in your list, compare it to the list, and it should count everyone it finds. And then return that number. And then you can return. Once you return that number, all you got to do is print it out like this. Put the number in here, write your little sentence, print it out like that.